basically what it is.
Mercury is no longer used in thermometers. What is used in thermometers now is basically just alcohol with a little red dye
right now.
So that's
dealing
much
conversion
safer,
factors
than
that is going
mercury.
to
I think it'd be hard pressed to find. I think there may be a few mercury thermometers still around,
lots of unit
pretty much gotten rid of all of those because it's just too dangerous.
For instance,
what other liquids? So we got
you have this sort of
water, coffee,
of a metal, for instance.
Blood?
And then the question will be, well,
blood. Hopefully, you don't come into contact with blood every day, but I guess
how much of
if it's inside,
this metal can you make?
or maybe you're in a hospital.
Well, then you need to take them,
come into contact with it. What about gases?
We're going to be getting to, and then you've got to convert those moles back to grams, and then grams.
Steam,
back to
okay.
moles, and then basically what we're going to do is
cooking every day. You're definitely going to come into contact with some steam,
which is find out what
else
unit you have,
Nitrogen,
and then
you're going to come into contact with nitrogen
at the end.
Air.
So what are the steps of going from
air,
the unit
oxygen?
you have,
So is
converting
air
it to the
a heterogeneous mixture or a homogeneous
if you can
mixture?
do that.
homogeneous.
I mean, like really,
Yeah, it should be. I think I was talking with this with one group. If it's heterogeneous, you're probably in trouble. That probably means there's like a
very, very
smoke, or
important
means there's a fire
to know
somewhere
how to
or
do.
something. You want to avoid
Our
that
lab
if at
next
all
week
possible. What
is gonna
about,
be all about
any pure substances?
learning the difference between
That's a little
accuracy
trickier.
and
What
precision.
pure substances
Now,
would you
this
come
is
in
really
contact
important
with?
too. Can anyone tell me what the difference is between accuracy
Water?
and precision? What does precision mean?
I doubt you come in contact with pure water.
Precision is like
Even if it's coming out of your tap, that is not pure water.
Very
There's
good.
ions
That's right.
in it. There's
Yeah.
metal
So if you-
ions in it.
What
There's,
you want
buffer ions in it.
science.
What about,
So
like,
I'd like to have both
alcohol, like
accuracy
hand sanitizer.
and precision.
That's
But
only
which one do you
70%
think is more important?
alcohol,
Accuracy or
and
precision?
normally has
Accuracy.
like fragrances and other
Accuracy.
things.
What's
in
the
it, too.
difference?
So that
Isn't
wouldn't
it
be
the same
pure
thing?
either.
iron.
Silver. Precision, you can be
maybe
far off,
silver.
but they can still,
Silver?
like multiple tests can still
Sugar.
be precise.
There you go. Yes,
Whereas-
sugar.
Right?
Most
What's
if it's
what's
really
the difference?
pure, like
So what does
pure
accuracy mean?
white granular sugar, is probably
This is like how
going to
close
be
it is to
about
the
as
target.
pure a substance as
Right, how close it
you're
is
gonna
to the
find
correct
typically.
answer. Exactly.
Um,
And people get that
but
confused
even then,
all
it's
the
probably
time.
going to have some impurities.
I know when I
in
was
it.
an undergraduate taking,
But yeah, iron.
analytical
Someone
chemistry
mentioned
or
iron.
anal chemistry.
Iron is really hard to find in a pure.
You do these really
in a pure
elaborate
way. Like even like
experiments,
stainless
and you'd
steel
be
is not
super
pure
stoked if you got
substance. That has
the-
all kinds of
like
things
if you
in
did
it.
3
different metals, and
versions of the
there's,
same experiment,
carbon
you're
in
gonna
it,
get
all
all really
sorts of
close
different
together.
stuff.
Yes,
So you came
I
up with a
nailed
lot
it.
of different things.
Then you'd
Okay.
you'd wind up with a C.
So what
because you were
about?
extremely
Let's just
precise?
we can do these
totally
ones together
wrong is
too.
what the actual answer was.
How many significant
So
figures?
we're
in
going to learn that when
1A?
you're talking about things in scientific
Yeah,
terms is
two.
really important
Because
to be able to
we
convey
ignore any zeros that come before
whatever
non-zero
audience you're
numbers.
talking to.
So
How accurate
Any
or how precise
zeros that
these
are to the
numbers are.
left of
And
non-zero
since we're
numbers,
going to be
they're
dealing
going
with
to be
numbers a lot,
insignificant.
obviously. I mean,
because
math
basically they're
and
just what
chemistry
we just call
go
them
together like this.
placeholders. They basically tell us
Numbers
how big or how
have a
small
lot more
the actual
meaning,
number is.
but
But
than
that's
you
it.
think they
So
do.
yeah, so
The
2
number
for that
two-
one. What about the next one?
Could mean a lot of different things. It could be something extremely
3.
precise,
Right. So
or something extremely imprecise.
same way. When you have zeros after,
2 is different from 2.
basically they're just placeholders too. So it just
What's
tells
the
us it's
difference
not
between those two
504, it's not 5,040, it's 50,400. So those last 2 zeros are also just placeholders. So that's 3.
Two
What about the last one?
like closest measurements.
What could you elaborate a little bit?
4.
What do you mean by that? 4.
So
That's
like,
right. So why is that different?
2
Why?
If it
Because
was like
here we've got
2.0 versus 2.000.
mhm. we
We
got
it's between
trailing
1.9
zeros. How come they're
2.1
significant?
versus like 2.0. Is it because it's after the decimal point?
That's right.
9999?
And basically
Right,
any
yeah,
number
one
that's in
is more
scientific
precise than the
notation
other.
by definition.
The other thing that
is
could also
significant.
show is that 2.00
So if I have
is a
1.06000
measurement,
times
and
10
two
to
is a count.
whatever it
If
is,
I count, if
all
I have 2
those
eggs,
numbers are significant.
and I say
because
I
if they
have 2
weren't
eggs, I
significant,
can't get more precise
we
than
wouldn't
that.
include
2.
them.
I mean, that's all there is.
Right. So there's 4.
That would actually, how many, So you've been learning about
what about
significant
2A?
digits, right? You've been learning about significant digits in lecture so far.
What number would
If I
that be?
count 2 eggs, how many significant digits is that?
So we write down 6, 5, 0, 5. Then
One.
how many zeros do we
One.
put at
Okay.
following?
Anybody else disagree?
5, right? Because basically we just go 1, 2, 3, and then 5 more. So 1, 2, 3,
You're all
4,
wrong.
5.
That is
So
an infinite number of significant digits.
650,500,000.
Because it's a count. It's
What
not a
about
measurement.
2B?
We only talk about significant digits when we're actually measuring something.
0.0330.
And I'm not measuring 2 eggs. I'm counting them. There is no more precision that can be made than 2. I've got 1 egg, I got 2
So
eggs.
minus
Can't
2,
get
so
any
we
more
have
precise than
minus
that.
1, minus 2.
So that is an
Yep.
infinite number of significant
That's
digits.
right.
So for
And,
instance, if
C.
each egg, if the average mass of each egg was like, say, 10.00 grams, the mass of 2 eggs would be 20.00 grams. It wouldn't be 20. We wouldn't
2.
round
So we
off
go
because of the
4.
number of
We
significant
move our
digits.
decimal
Number
4
two.
places this
So
time.
that's a
So
bit of a,
1,
that's a bit of a
2,
trick
3,
question.
4.
But we'll
Right.
go over that today. in
3A,
in-
we can
in
do
a lot
that
of
one.
these questions. So does anybody have any questions about the topics you've been covering so far before we break into rooms and start working on these things?
5.0900 times 10 to the
Or have I just
negative
confused
fourth
you
power.
enough with the whole egg thing?
So 1, 2, 3, 4. Right. Minus 4. Okay.
Oh, is
what
our
the
TA
B?
here today?
Hi, Professor. I'm here.
Yes, you want to introduce yourself. Turn on your camera and introduce yourself to everybody.
Sure. Hi, everyone. My name is Ben, and
3B,
I'm
who
the TA
wants to
for
do that
Chem
one?
210. So I've previously taken this class, not at this college, but recently, so the material is still fresh in my mind.
3000.
If you need to contact me,
10
you
raised to
can
7.
either reach me at the STEM Center,
0,
virtual
0,
STEM
0
Center.
times 10 to the
Times
7.
email
So do we
I'll,
include those
actually,
zeros?
Make an announcement after the session with all
Oh,
my
no,
contact
sorry.
information and my
No,
numbers.
we don't. That's right. We
So
don't
you guys
include
can,
those because
It's not on
Make,
this.
adjust
they're trailing zeros. If that's right, if there was a decimal
Thanks,
there,
Benjamin.
we would
Yeah, if you
include
could
them.
put, or
Because
Yeah.
the
Benjamin or
decimal
Ben,
tells
which
us
do you prefer?
that it would be plus or minus
Benjamin's
1.
fine.
Okay.
Because there isn't, basically we're dealing with plus
if
or
you could-
minus
if,
1,000.
if you could pop your
So there's
email
a
address
big
in
difference
in the chat, that'd
in
be
how
helpful. And
accurate
also, we can
or
find
how
you on
precise
Canvas as well, right?
that number
You have your
is.
own module
Yes.
there.
What about C?
Yeah. Let me
Yeah,
type
so
that in
there's
real quick.
so just like Dr. Sanders' contact information is there,
5.3
my contact
times 10
information is
to the
there,
negative
Benjamin's
12.
contact information is going to be there as well.
It's already
So
there.
minus 9, and we
Yeah,
go
and so
1,
you have
2,
a
3.
particular
Right. So
time that you'll be
minus 12.
at the STEM Center.
and then the last one.
Okay, and they can contact you if they have any questions pretty much at any time as far as email goes.
The last one was D.
Okay.
Yep, 3D.
So
It was
Benjamin and I are gonna be going,
2.0200 times 10 to
back
the
and forth
second.
through all the different breakout rooms to see how you're doing.
So move
what I figured we would
1, 2.
do
Yeah.
is
So we
work
have to
on a couple of
include
these
those
as a
zeros
group,
because they're
then
after the decimal
break
point.
into.
And so the only reason
Okay.
for including them
So for
is because we
instance,
could measure that accurately. Meaning it's not
If you have-
plus or minus
if you-
1,
if
it's not
people
plus or
looked at these
minus
questions
0.1,
already?
it's actually plus or minus 0.001. So it's much more accurate. So if you have an instrument that can make that measurement that accurately, you
No.
don't waste
No,
the
nobody.
accuracy.
Okay.
You include it.
So
Okay.
classic question here. You're in the pharmacy. You got your
Now
mask
let's
on,
go
of course,
to
and you see something labeled chemical.
these. So I think
So basically
4A,
what
how
they're
would we
meaning, when people say
approach
chemical
that?
free, meaning like they usually mean nothing artificial. And then, of course, the meaning of artificial versus natural is subject to debate as well. So, is this sunscreen
240.0.
really chemical free? What do
So
you think?
why do you give that answer? How do you come up with that?
If you look at the listed
Basically, you
ingredients,
times it.
are those chemicals or not?
Then the least significant
Yeah.
figures, that's what you're gonna use for
Why?
your answer.
Right. So 6 has how many significant figures?
Dioxide, that sounds like a chemical.
Get it?
Um,
And do you
4.
know how
It's
you would?
4.
What is titanium?
Right, so our answer,
dioxide?
final
I know we're
answer
getting a
should
little
have 4
ahead of
in
ourselves.
it.
What does that
Now
mean?
with
That's a
4B, how do
molecule,
you
right?
how do you
That is not an atom.
approach that problem?
Can you tell how many atoms there are of each one in titanium dioxide?
You do the parentheses first.
Right.
Two
Just like, we
oxygen,
learned
one
in,
That's right.
I don't know, high school, middle school,
Yeah,
wherever
when you
you learned
have
it.
di,
Always solve for
mono,
the
di,
brackets
tri,
first.
tetra, we'll find out that those.
So how many
you probably
significant
already know
digits?
that means one,
I have 3
two.
significant digits here,
So if
and
you have
3
titanium
significant digits
dioxide, that
there.
means a
But when I
molecule of
add
one
them, what
atom
do
of
I get?
titanium, 2 atoms of oxygen.
So
What
when I
about
take
vitamin E and vitamin C?
61.2 and
Do we
add
consider those chemicals as well?
88.5,
4
what's my,
significant figures.
right, you get 4. So that's right. So
I don't
what's
think we
what's
do
the what's my
because
answer
they're
here?
naturally occurring.
149.7.
Okay,
149.7.
they are naturally occurring.
So,
Obviously,
unlike,
fish oil has a lot of vitamin E in it.
division or
citrus fruits
multiplication,
has a lot of vitamin C in it.
when we add numbers,
If they
we
occur
look and
naturally,
see
are they not
which
chemical
one
anymore?
has which one has the
They're not
most
genetically
significant digits
modified?
after
Perhaps.
the
They're not genetically
the,
modified, but
the
are
decimal
they
place.
chemicals?
And they both have 1.
What's the
so we're going
difference
to use
between a
1,
chemical
and then whatever
and a
numbers
molecule?
happen before the decimal, that's what it's going to be. So we have 3 significant, but the answer has
Chemicals
4.
are made up of
So
one
how
or
many
more elements.
decimal places, how many significant digits will my final
molecules?
answer have?
Molecules are made of only one element or
For,
one
for,
atom.
for 4B.
Nope.
Whatever the answer is, how many significant digits
Molecule
should
can be
be
made
in
up
the
of
answer?
one element, like a molecule of oxygen.
Four.
It's basically just 2 atoms of
Right.
oxygen.
Because there's 5
But,
significant digits
carbon
here.
dioxide
There's 4 there,
is
so my
also
final
a
answer should have
It has
4.
carbon and oxygen.
What about
So
4C?
is there a difference between a chemical and a molecule? I mean, I think in the public
There's-
imagination there is, like someone mentioned,
You just add and then
molecule occurs
round to 2
naturally and a
decimal
chemical
places.
is made in a lab somewhere. But is that the truth? Is that always the case?
So add them together. And so when you do add them together, give me all the digits. So what would be so if you add these
think
2 together, what's the
There is
what's the answer with all
chemical
digits?
compounds,
7,
natural
then
and also
3 carry the
man-made.
1, 2.
So, for example, on
Oh.
plants, there are a lot of chemicals.
I was going for
Well, just use your calculator.
There
Just
are
add them
molecules
together.
into them.
So you think the molecules together, when they come together, make a chemical? Is that
37.
Is that your argument?
Well, that's what I'm saying. I'm not. I could be wrong. I don't know. I'm not sure.
okay?
37.
No, I
So
mean,
what's
there's no wrong answer
what's
here. I'm kind
the
of
final
looking
answer?
at what are people's opinions, because I know that
37.
natural and organic, just the meaning
Right, so
of
we
the word
round
organic
up.
is
So we have a
pretty
7 here, so this rounds
much
up to
I mean,
4.
because every
So
state
then our
has their own take
final
on what
answer,
organic
since we
Go
this
to the store
this
and get
number
an organic
basically
apple.
is
It
we were
means
limited
a
with
lot
the
of
with the
different
precision on that one.
Um,
Although we still
But
use
my-
it,
sort of
it's
the
not like
point
we
I
just
wanna
get
make
rid
is
of
that
it.
There's a difference
But
in what
We use it to figure
the
out how
average
many
person on the street
decimals
thinks is a
after
chemical and a
or how many digits
then
after the
now that
decimal
you're
point we can
chemists,
use, and we're sort of stuck with
there's no
only
difference.
using 2.
A chemical
And then the
is a
last one,
molecule.
how do we
There's
do?
no
How do we deal with that
difference. It's just a collection of atoms that are linked together. That's all they are. And whether or not it's a naturally
try
occurring
4D,
thing
take
or
a
it's
crack at that one.
synthetic thing made in a lab, it's still
what
the
I did
same
was
thing.
I
Now, if you want to get
multiplied it
into
all
an
out,
argument
so I
about organic
did the
versus
8
natural
with
versus
15.
synthetic, that's
So
a
with 12
whole
more
other
zeros,
thing.
and then
But
um,
nothing
I
is truly
did
chemical free. It's
7,
a vacuum is
70
chemical free, but
so
other than that,
basically
it's going to have some
8
sort of
trillion
element or
plus
molecule
72
or
trillion,
compound or
which
chemical in it.
is 80
Is that-
trillion.
that-
And then
Would you agree or
you
disagree
would
with that
do
assertion?
3 significant figures, which is 8.00 times 10 to the 16. Agree.
8.00
So wait.
times 10 to the
Agree with
what was it?
heartily, or just, if I just browbeat you into
10 to the
agreeing?
16.
I mean, you have a
So the other way to
PhD,
do it
so
was just
Oh, I'm just going to write
convert them
about
both
everything.
to the same
You know what that
power.
means, right?
Either
That means
convert
I
them
know an
both to the
awful lot
15 or
about one
convert them both to the
tiny
16.
completely
If we convert them both to 16, then we've got
Don't think I know everything about chemistry. Nobody does.
0.800
If you have a PhD in
Zero.
organic chemistry, you may not know anything about
plus
If you have a PhD in inorganic
7.20
chemistry, you may know nothing about organic.
times 10
and
to the
so it
16.
goes.
And then you just add those together and you get the same
Okay.
answer.
Oh, yeah. So,
So it's a little
David, you had a
quicker
question, I think.
than putting all those zeros
Whoever it
there.
was. Somebody
but
had a question.
You get the
No,
same answer.
that's a mistake,
So,
sorry.
Yeah, well done.
That was me, my bad.
All right. So group.
So there's no
one.
difference at all?
No. Going to give us your answer
I
for
don't-
number
I
one
don't
there.
think so. I mean, I think in the public imagination there is, but chemical.
Who's speaking for group one?
Just
I can't remember what
means
Marianne, what
something
group
made
one?
of atoms. That's all.
Yeah, that was us.
Okay. How'd you approach
Chemical
that
is
one?
Something made of
Let me
atoms,
try
and
to
that
get it
is everything. So I mean,
This is number
basically
one,
everything can be considered
the,
a chemical
Oh, sorry, I'm
or a
pulling up the wrong
molecule.
notes.
Molecule, chemical, basically the same. Basically the same.
And have them side by side. Okay.
We'll get to the
We'll
difference between
convert
atoms and molecules.
8.23, okay.
In a minute.
So what we first did was add centigrams to kilograms. So 8.23 times 10
Let's
to
look
11
at
powered
right here,
centigrams to
very first
kilograms.
topic.
So what we
So
looked it up
let's-
online because we
let's
couldn't find on the
think
conversion
about
sheet
this
was
for a minute. How
centigrams
does an
is
atom differ from a molecule?
100,000
How are they the
centigrams
same?
into 1
First
kilogram.
of all, how are they different?
Okay.
What's the difference between an atom?
So
and
when we did the math,
you can do it that way. I think probably on a
one atom.
test,
Mhm.
probably the simple.
Right, in an atom,
you won't be able to
obviously, is
use
just one.
to look up the
Is
conversions
there
online.
anything
Yeah.
else
You're
different?
probably better just going through grams, figuring out taking
So then an atom
centigrams,
would be way
yeah,
smaller.
converting
10
those
and
to
then-
grams.
yeah.
It depends on the
then
atom, right? Like an
taking
atom of uranium
grams and then
is
converting those to
huge,
kilograms.
and an atom
Okay.
of hydrogen
Either-
is tiny, tiny,
but
tiny.
as long as
But
you-
a molecule of
10
hydrogen-
Right now you don't have to do that.
So actually,
Yeah.
it would be
But,
smaller
yeah.
than
Okay.
an atom of
So then obviously we just took
so
the
it depends on the
8.23
relative
and
size. We'll find out
or
that
8, whatever
atoms
number that
vary in
is,
size.
and then
tremendously.
divided that all by 100,000, or you could do the double step. where it's-
That's the main.
I think it's
difference, is that
100
an
and then
atom is just a
1,000.
single.
And then we ended up with
atom, and a molecule
8.23
is more than one.
times
Can a
10 to the
molecule-
6
what else is
power kilograms.
different about them?
Right, because you've
The
got
molecule can be made up
10
of
to the
different
2
atoms, or is the atoms just going
for
to
the
be
centigrams, so
singular
10 to the-
element?
and 10 to the minus 2.
Very good. Yeah, an
And you
atom
got
is
10 to the
basically
3
the
as far as
smallest part
grams per
of
kilogram.
an
So you got
element
10 to
you
the
can
2
get.
centigrams
I mean, that's
in a
the
gram.
defining.
Then you got 10 to the third grams
of an
in a
atom. You can
kilogram. So
split an
yeah,
element into
you
smaller
basically
and
get to the
smaller and
same,
smaller and smaller
get to the
pieces
same
until
answer.
eventually you can't. That's
Okay,
the
so
smallest.
group 2, what'd you
Yeah.
get for number
A
2?
molecule can be made
How'd
up
you go
of one
about it?
atom or 2 or 3 or 10 or
Excuse me?
they could be.
How did you go about
like DNA
getting
would be made up of,
the
like,
answer for
really
group 2?
long,
Oh yeah, Arissa,
structures
yeah, go ahead. Well,
of
Thank you.
atoms.
yeah.
So
Bye-bye.
how are they the same? This is a little more difficult.
So group
actually.
group 2,
How are
how
they
did you
similar?
approach that problem?
Yeah,
think of
so
one
it says
thing right
here
off the bat,
118
but
miles
maybe
per
not.
hour in meters per second. So
Mhm.
basically we look up for how many miles
Wouldn't
in
it be like the same
in a second.
composition?
So there's
Well,
a
there
point.
aren't miles in a second.
Oh yeah,
Same
meter, sorry.
composition.
There you go.
Well, I mean,
So,
CO2, carbon dioxide, is composed of one atom of carbon and 2 of oxygen. How is that similar to the composition of an atom?
So there's
Like, I guess you would
0.01
just be
miles per
taking
hour
it and then combining
in,
it?
Combining what?
Like
and there's
two
0.004704
Mm-hmm. Okay, but are they similar in
meters
in
per
that way?
second. So we just
Are they different?
calculated.
It sounds like a
and
way
we
that
came
that,
up with
that,
the answer
that
of
they're different.
Yeah, that's true.
Okay.
The complexity.
52.75072
Wow. Okay. Man, you're getting all
meter per
philosophical on
second.
me.
Okay, a couple
so they're
problems there.
similar
So
in
you're
complexity. What is that
converting
mean?
both
Yes.
units at once, which is
Well,
a
I
bit
was thinking that they are
problematic.
different in complexity.
Yeah.
And the other problem
Oh,
is
yes.
how many significant digits
Yes.
is
Thinking
your
that
final
one
answer be?
atom is like single, and then the
We have
molecules are
7
many of them.
significant figures.
Yeah. By definition,
hold
a
on.
molecule is more complex
Yeah.
than an atom.
Well,
just
you've
because of
given
the
me
number.
7
So, yeah,
significant
that's great.
figures, but that's
yes.
more than you should. How many
so what ways
significant
are they the
figures
same,
should there
though?
be in your final answer?
They're the same. They both include some sort of atoms.
So I think it's supposed to be
Well, they're
Well,
both, made,
50.7.
they're both made of atoms. That's true. One has just one of them, the other has many.
52.751.
Okay,
Nope.
that's true.
Remember, when
What
you're
other
doing
ways are they-
conversions,
are they
you
similar?
always, when you save all the significant digits, so I agree with what you've done so far, as far as have all the
What
digits
have you learned
there.
so far
But
about,
then, at the end,
what composes
you have to
an
go
atom?
back
What are
and
what are
see
the substituent parts of
what did
an
I
atom?
start
What are the
with?
particles
What
that
number
make up
did I
an
start
atom?
with? how many significant digits did
Protons,
it
neutrons,
have?
and electrons.
Because basically that will limit the number of
And you think
significant
molecules
digits
are made
you
out
can
of
have in your
protons,
answer.
neutrons, and
Because your
electrons?
final answer can't be more
Yeah,
precise
so that's something they have in common, right? They're
than
both
the
made
original
of the same subatomic
you can't,
particles.
so they have that in common.
What is
So
it about
52.8?
an atom?
Yes,
Do they have?
Yes.
So what is it
you have
about the numbers
118,
of,
there's three
of
significant digits there.
subatomic particles
Oh, okay.
that
So you should have
Yeah.
three significant
They have
digits
something
in your
that's the
final
same
answer.
number.
The other thing I would
What
recommend
subatomic particles
is
do they have the
taking
same
your
number of?
miles
Protons
per
and
hour,
neutrons.
converting the miles
Taking a
to
different
meters.
taking a different numbers of those.
So you
The
multiply
nuclear,
that
one
by
nuclear.
meters over
Well,
miles,
they only have one nucleus. Okay.
and then you also
there's-
multiply
there's the
that
three
by
Subatomic particles that
seconds.
that we could, well, obviously there's a lot more, but just for
hours
starters, we
over
think
seconds.
about the main
Because you
three.
want to do those
Protons,
conversions
electrons,
separately
and
to make
neutrons.
sure you don't make
Two of those,
to make a
two out of those
to make a
three
mistake. You want to
have
do
the
it one step at a
same
time.
number.
Oh,
Obviously, you
in an
don't have
atom.
to do that, but
Which
I would
two
recommend
are they?
doing that.
So we
because
know
then
that it's not
I
protons
think
and
you
neutrons,
make
but those can
fewer
be different.
errors that way. Okay,
okay. Thank you, sir.
So we can
No
eliminate
problem.
that.
so what about number 4? So group
Electrons.
3, who can answer
Electrons and
number
which
3
other
for
one?
me?
I think that was my group. I'll answer for
protons
Okay.
and electrons.
So
Right. Why is that? What does that
we
mean
just
for an
looked up
atom?
how
If you have the
many
same number of
cubic meters
protons
were
and the
in a
same
liter,
number of
and
electrons, what does that mean
found
for the
that
charge
it was
of an atom?
0.001 cubic meters.
neutrally
So
charged?
I
It's neutral,
divided.
exactly. What about
We divided
what about in
0.00057.
Ooh, now, one other thing I want to point out before you go any further. When you're doing these sorts of
If you
conversions,
take
never
all of
divide
the
anything.
protons from the
Ever.
atoms in
Always
in,
multiply.
in a
The
molecule.
reason
and
for
all
that
the electrons in
is
that
when I'm
molecule, do they also
multiplying,
equal each other?
I have
It would make
meters
sense.
cubed and I want to
they
go
did.
to liters.
They
If I
do.
start
They
dividing,
do. And if they don't,
then I
what do we
lose
have?
track of like where my
We'll have
unit should
either
go.
a
So I
positively
always
charged,
multiply. That way, I have units on the top
element
and I have
or
units on the
particle
bottom,
or
and so I can
molecule or
cross
whatever.
out.
And
And when
then-
I'm
or
starting
a
to,
negatively
when I'm dividing,
charged,
it makes
molecule.
unit. It makes
Right. So
unit,
what do we call a positive or negatively
conversion
charged
or
atom or
elimination?
molecule?
Much
Ion?
more
An
difficult.
ion.
Because
Bingo.
then
That's
I've
what I was
you know,
getting at. So
I've got centimeters
that's
cubed on
the
one, and I'm
main way.
multiplying.
One of the
I'm
main
dividing
ways
by
that an
centimeters to
atom
the
and a
minus 3.
molecule
Am I
are
supposed to
similar.
add those? Am I
They
supposed
both
to subtract those?
have no charge.
You know,
no
it makes it a
net
lot harder.
charge. They have the
So I
same
always,
number of electrons
always
and the same
multiply.
number of protons.
That's
so
just
there's no
something you
charge
want
to them.
to
So
think
an
about. It'll
atom
make your life a
and
lot
a
easier
molecule
when
are
you're
both
doing
electrically
that. Okay.
neutral. So they have no charge.
Okay,
The minute
so
they
then
either gain an extra.
So how do you go from
become negatively
cubic
charged,
meters? What's
then they're
the
negative
conversion
ions, or
of
they
cubic
lose an
meters to
electron,
liters?
So now they have one more proton.
they're
They become a
the
positive
conversion from
ion.
cubic meters
And
to
as we
liters
go
is
forward,
that
we'll
there would
see
be
So I want
some
liters, so that
atoms
would go on the top.
that are
And
much
meters
more
cubed
stable
would
as
go on the
positive
bottom.
ions,
yeah.
and
There's
there's some
1
atoms
liter on the
that
top,
are
and then
much more stable
0.001
negative
meters cubed at the
ions,
bottom.
depending on where they are in the periodic
0.001.
table.
Okay.
We'll find that as you go from
And then
left
after the
to right,
calculation, we got
atoms tend to become more and more and more
0.575
negative.
liters
Atoms on
as
the
the
way
answer.
left side of the periodic table become positive
So
ions.
we
And
go
atoms
1, 2,
way to the left,
3.
or way to the right on the periodic
1,
table.
2, 3. So 10 to the
Further
minus
right
3.
of the
So we
periodic table,
go
tend
1,
to become
2, 3.
negatively charged.
And so how many? What was your
And the
final
same is
answer?
true with molecules. They don't have a charge either, but they can also be
0.575
ions.
liters. I should instead
So,
convert that into scientific
Let's
notation.
go down.
or
We'll
is
do
that
number
good?
2, and then we'll break.
No, I think no. If
into
it doesn't
groups.
say
Okay,
if
some
it
of these
doesn't say
things,
scientific
it's gonna
notation, you don't have to
take
do
some
that.
thought.
Okay, perfect.
So
Thank you.
classify each.
So yeah,
as
so
an
the other way
element,
we sort of
compound, or mixture. What's the
to
difference
do it that way,
between a
but
compound
the way we
and a
sort of
mixture?
normally do it is
Anyone tell
that
me what
we
the
use the
difference is?
conversion that, because that's easier for me to remember, is that 1 liter is equal to
A
1,000 cubic
compound is
centimeters.
made of
So
uniformly
normally what we would
distributed
do is convert
molecules,
meters cubed
while
to
a
centimeters
mixture is
cubed.
multiple
And once you
substances
do
mixed
that,
together.
that's
Like
automatically
a
liters.
compound
So
is a pure
do it
substance,
either
while
way.
a
You should
mixture
get
is a
you should get
mixture
the
of
same
different
answer.
substances.
Okay.
Okay.
Nailed it.
So a meter
Yeah,
cubed
exactly.
would be 100.
A compound. I could
1 meter is
have,
100.
a pound of it, or a
centimeters,
kilogram
right?
of it, or a gram
So
of it.
100
but it's all the
centimeters
same.
cubed
And so we call it
is
a homogeneous
10 to the second times 10 to the sixth
because there's nothing else
cubic
in it.
centimeters.
If I have like a,
so 1 cubic meter is 10 to the
pure
sixth
water.
cubic
If I have a
centimeters.
glass of
You
pure
just did it
water.
the other
It's
way
got
around.
nothing else.
But you get
but
the same
H2O
answer either way.
Nothing else there, which is we'll find out later.
All right,
is
cool.
basically
So
yeah.
number
But
4 we did
for the
as a
meantime,
group.
we'll just think about
Number
so pure
5,
water,
I think we
nothing-
did that as a
nothing else in
group
there.
as
A
well.
mixture would have
What
all
about
kinds of
number
different
6?
atoms,
Group
compounds, and whatever.
4. Did you do number,
All right, so the
did you do
first
number
one,
6?
copper. What would we consider that?
An element?
An element.
Hello?
Yeah, that's an element.
Oh, you mean group
So,
5?
like
Oh,
a
Oh,
yeah,
group 5.
copper
Sorry,
wire.
I just talked to group 4. Yeah,
As
group
long
5.
as it wasn't rusty or anything, it would be elemental. There would only be copper
Is
atoms.
it 16.0
The minute it rusted,
times
what does that mean
3.785?
if a metal rusts?
Wait, is the answer 60.56?
What happens when something rusts? What does that mean?
Sorry. Do you want to just
got
take me through the
oxidized.
steps? Why don't we just
Right. So it
do that.
reacted with what
Yeah, let's
other
put up
atom?
a blank screen. Let's just go through it. All right. So what was? So we have 16 gallons.
Oxygen, exactly. And we'll find out that oxygen is hella reactive. It reacts with basically everything.
So where did you
And
go
so,
from there?
Rust, we typically think about rust as
And I
iron
multiplied
oxide.
it by
but
3.785
oxygen can
liters.
pretty much oxidize
Over
almost
1 gallon?
any metal, with some
Yeah,
exceptions.
So where'd that
like
number?
gold
3.785.
doesn't oxidize gold very well. Silver
liters
doesn't
per
oxidize
gallon. So
silver
that's
very well.
the
You'd still
one you
get
found online.
those things made. But yeah, oxygen is super
Yes.
reactive. What about water?
Okay.
Element, compound, mixture.
And then is liter the same as
Yeah, compound. Made up of a 2 atoms of, so the molecule, it's a basically,
what's the next
it's
conversion
a,
you
it's
have
a,
to do?
It's a solution
Because we need to
of
convert
molecules.
volume
So it's a
to mass.
it's a compound.
So we're given the density, since
nitrogen?
that's a ratio of volume to mass. But our density is in what units?
that is a trick.
The density
question.
is in
You're right.
0.671
What else would be a
grams
correct answer?
per cubic centimeter. Isn't that the density? Or
Yeah.
grams per mil? Is that it? Grams per mil?
A compound?
Yeah.
Mhm.
Yeah.
What compound? Do you know?
Find a cubic centimeter is the same as a mil. So it's the same thing. So 1 mil. Oops.
The nitrous.
No, the minute you say
So what do we do
nitrous,
with this number we've got
We'll
so
find
far?
out
So
that
far,
means
we've
plus
converted
oxygen.
gallons to
So
liters.
that wouldn't be
What do we have to do
just
next?
nitrogen. But what form of nitrogen is it that we breathe? Like 78% approximately of the atmosphere is nitrogen. You're breathing nitrogen right now.
I don't know. Stuck.
Are you breathing nitrogen?
Well,
atoms,
we've got
or are you
our
breathing
density is
nitrogen
in
molecules.
milliliters. Also,
Oh, right.
also
So-
volume. So basically, we just have to change
You're
the
breathing
volume.
nitrogen.
So we want
molecules.
milliliters.
You're breathing nitrogen in the form of.
So we don't want
N2.
liters. So remember, when we don't
And
want
we'll
something,
find that
we put it
naturally
in the
occurring
denominator.
nitrogen, that's the
And
the
naturally
number
occurring
we do
nitrogen
want, we
gas
put it
that
in the
you're
numerator.
breathing right now.
So
is
multiplied
not
by
It's a
1,000
molecule.
milliliters
It's two
over
atoms
1
of
milliliter.
nitrogen
Exactly.
Oh, 1 liter.
coming together.
Yep, 1,000
And we'll
milliliters
learn
in 1 liter.
Why that is.
So that gets
Basically,
rid
a
of our
single atom
liters.
of nitrogen is
So
super,
now
super
we've gone
reactive.
from
A single
gallons
atom of
to
oxygen is
milliliters,
super,
and that's
super
what we
reactive.
want, because
So
the
reactive
next
that they basically
thing we
react
do
with each
is
other
multiply by the
to make a
density.
stable compound.
And we've got
And nitrogen
milliliters right there
is
in the
N2,
denominator.
is
So
really
we're good to go.
stable.
So
It's
now
super
we
stable.
get rid of our milliliters in the numerator.
Basically, there's
milliliters
very
in
few
the
things that you
denominator.
can make.
And what's the
nitrogen
only unit we have left?
And in fact, chemists who are doing
Grams?
like synthetic
Grams.
chemists who are like doing these really complex
Unfortunately,
reactions,
we don't want
different-
grams,
different
do we?
chemicals, and they don't want
What do we
oxygen to
get
get
want?
involved and screw everything up.
Kilograms?
Basically,
Kilograms. We need to do one more. Man, this question has so many conversions
with
in it.
nitrogen to make
So
sure
the
that,
unit we want is kilograms.
no other
that
side
goes in the
reactions
numerator.
involving
The
oxygen.
unit we want to get rid of, we put
So
that in
nitrogen
in the
is a
denominator.
molecule.
So how many grams in a kilogram?
and an element. It's a compound and an element. What about T?
Oh,
What
Like
is-
a nice cup
what
of
does
tea.
kilo
What is
stand
that?
for?
So there's
Is that a mixture?
It's a mixture. It's a mixture of
0.001
what?
kilograms in a gram.
Yeah, you could do it that way. I find it much easier to remember that there's 1,000 grams in it.
Yeah, so it's mostly water.
That's what kilo
right?
means.
I mean,
kilo
the
means
vast
1,000.
majority of it's going
So
to be
I just
water.
like to
But
do
then
it
you're
that
going to
way,
have
because the other way I get
whole
confused.
host of like
I'm too old
thousands
to be
of other
confused, so I
compounds
just
in there.
I
We haven't
want to
even
make it as
identified
easy
what
for
they all
myself
are.
as I can.
Some of them are there in
So
like
now,
small amounts.
Our grams are
Very
gone.
difficult to
And the
determine.
only
But
unit
there
we
are
have left
thousands and thousands
is the one we want.
of different.
So now all we got to do
compounds
is multiply
in a
everything in the
simple cup of tea.
numerators,
And every
and
time
divide
you
by
make
everything
it,
in the
depending on the temperature of the
denominators.
water you use hotter water.
And
you'll
since we have
extract
1,000 in the
different
numerator and 1,000 in the
molecules
denominator, we can get rid of
other than
that.
tea leaves.
So really all we
Colder
need to do
water
is multiply
will extract
16
different
times
compounds.
3.75
So every time you make a cup
times
of tea, it's not going to be
0.671.
exactly the same. Okay, so
I got
What I think would be-
40.63.
go ahead.
576.
No. Always interrupt me to ask questions. Sorry. Believe me. So, how many significant digits should there be in our answer?
So water is a
Is it 3?
compound, right?
3. Yeah, for 2 reasons. What are
Even
the
though it
2
has
reasons?
H2O.
The
Well,
gallons.
that's what makes it a compound. Yeah, because we have
16.
that's what makes it a compound.
Yep, because we
We'll
have
find out
3
that it's
significant
oxygen
digits
with
in
single
our-
bonds to 2 different hydrogen atoms.
We have 3 significant
So
digits
we'll
in
learn
our
all
original
about,
number.
covalent,
So it's the original volume we were
bonds,
given.
shares
only has 3
electrons.
significant digits.
This hydrogen
Where
shares
else do we have
electrons
only
with
have 3
oxygen, and this
significant
hydrogen shares electrons with the same oxygen atom. And so together, it's a
The-
single unit.
the
It
grams.
moves around and circulates as a single object.
Yeah, 0.671.
That's
So
not
when you
grams.
boil
That's,
it, for
that's the
instance,
density.
It doesn't change.
This is
It's
the
still
density.
water. You freeze it,
And that's the
in
number
ice,
we were
it's
given. That's
still
the
water.
conversion we
It
were
changed.
given. And
You
we were
haven't
given
changed
only
the
3
compound
significant
at all.
digits there.
It remains
6,
the
the
same
7, and the
thing.
1. So both of those
Okay,
things
makes
tell us there can only be
Until you can get it to
3
undergo
significant digits
a
in the
chemical
final
reaction.
answer.
But until you undergo
One
until you
other thing I
force it
want to
undergo
ask
a
you about,
chemical
though,
reaction.
since we
it
say that
stays
there's
water.
1,000
you can do whatever you want to it physically.
grams in a
Freeze it,
kilogram,
you can turn it into steam.
how many
put it under
significant digits
pressure,
are there in the
whatever
number
you do to it.
1,000?
Physically, it does not change. Chemically, it'll change.
There isn't
Okay.
any.
Well, it's got to be some significant digits, or it wouldn't
All
be a
right. So
number at
figure
all.
it's 4.
what I would do is
4?
we would
No,
go
one,
into
one.
groups.
There's just one.
You could start.
So how come we
working
don't
on
limit
some
our
of these
answer to 1?
problems? And then
Because it's
Benjamin
not
and I are
part
going
of
to go around to the
the-
different rooms, see how you're doing. Now, what I would like
It's a
is
measuring,
for
like,
in each of
like
the
conversion,
each of the
so
different
it's not
breakout
part of-
rooms
I don't know.
have
explain.
one person.
Well, the way to think about it is, it is, yeah, you're right.
sharing
It
their-
isn't a
sharing their
measurement.
screen. Hopefully, everybody
That's
has
not a
this,
measurement. It's a count. And
has this
counts are
document
exact.
already, right? The
There
second
are
recitation.
exactly
You may not have looked at it,
1,000
but at least you
grams in a
have it
kilogram.
with you.
There's not 999.
Does
There's
everyone have
not,
one?
1,001. There's
just
not
in case.
1,000.0001.
I
There
think-
is
I think
exactly
another
1,000.
issue is that you can't
And
share your
when you
screens. I don't
count
think, unless
something,
you found a
there's
way
an
to
infinite
allow
number
it.
of significant digits there.
Oh yeah, I'll allow it.
Like there are
Okay,
12
because in the
eggs
other
a dozen.
when we did the
Exactly.
Jambo board,
It's not
when we tried
a
last
little
time,
bit more or a little bit less than 12. It's
All right,
exactly
so yeah,
12.
I just allowed.
So there's an
screen sharing,
infinite
so-
number.
okay.
Anytime you
That-
count
that
anything,
should
that's
help.
an exact
Um,
number, and
so,
it's an infinite number
Yeah,
of
takes
significant digits.
takes down
Okay?
the information.
So
Okay.
only go on the measurements you're given. So
Somebody needs
gallons, that's a
because we're going to
measurement.
have about
Density,
let's say,
that's a measurement. So you can
half an hour,
so you have
45
to
minutes,
basically estimate those.
to work on
You'll
these.
never get it exactly.
So someone
It'll
should,
be a really good
someone
estimate.
from each
It'll
group
never
should,
be exact.
I'm going to go
All
around.
Great job.
And ask.
Okay, what's
each particular
the-
group to
go back.
present their solution to one of these problems? Okay. Oh, excellent. Thanks, Jexy.
Number
Just posted
7.
the recitation. there in the
I
chat
think
in
we're
case you don't
group
have it.
6.
So I'm going to go
Let's
to each
take that
group,
one.
and you're going to present one of these problems to the rest of us, right? And then we'll all
I just
discuss
finished
it.
that one, but I don't know if I did it right.
Okay.
So the first
let's-
couple are
let's put it up on the
basically,
big board. So how did you start?
and then later on we're going to go into more
So it
specific
said that there's an
questions.
aluminum rod, so a
And do
cylinder. So
People
the volume
have
of
you
the
done
cylinder
any of these problems? If like
is
pi
pi r squared times the
working
height.
how to change
maybe we should do one of these together.
Okay.
How you change
and
one
that
unit to another
it's
unit?
4.85
Have you done these
meters
sort of
long
problems
and
together?
6.25
Well, this
millimeters
would be the first time doing
for the
it.
radius. And its density is 2.7 grams per centimeter
Like,
cube.
are you asking
So
our entire lives
I
or just in
just converted everything
Yes,
to
the entire,
centimeters.
Right, you need to do that.
Yeah.
From birth to now. Have you
So,
have you done any of these unit
what'd you say?
conversion
So our
problems?
R is
Yeah,
what?
this was like 6 months old.
6.25 millimeters.
No.
6.25
Okay, why don't we do one
millimeters.
together then?
And
So we can.
the length, I guess the height.
4.85 meters.
So here we've got conversion factors
4.85
here, like converting
meters.
hours to minutes and
Right.
and
So
kilograms. to
that's
grams.
absolutely right. Is what you need to do is convert everything to centimeters,
should be
because when you multiply these two things, we have a unit of length here, we have a unit of
There
length
should be a
there.
guide.
So we
You don't
multiply
have
them
to
together, we're going
memorize
to get a
all
unit
these
of length
conversions. That would be ridiculous.
cubed.
There
So
should
it
be-
needs
I will
to
go look
equal
for it and then
centimeters.
post it.
So how did you
in the
get,
chat.
so
Basically
your
a
radius
table
now
of
becomes
all of these
how many
conversions,
centimeters?
because no one is expecting. I don't remember.
0.625
Like,
centimeters.
how many grams are there in
Right,
a
because
pound?
there is,
Somewhere around 4
centimeters.
but I don't remember the exact
and
number.
there is
We
10
don't want you to remember the exact number.
millimeters
We want you to be able
in
to
1
use that
centimeter.
information to convert from pounds to.
So we divide it by
grams. So
10.
That's the important.
Right, so that
thing.
is
So let's look at
0.625 centimeters. And how, and our height
Oh, here we go.
becomes how many?
Nanometers to kilometers.
485 centimeters.
So if you've been learning about the
we have
metric
100
system,
centimeters in
which
a meter.
one is smaller, a
So we multiply
nanometer
that one
or
by
a
100,
kilometer?
right? So that's now 485
Nanometers,
centimeters.
super small.
So
right.
we have pi.
How many
and
nanometers
you
are
can
there in a meter?
pi to as many digits as your calculator will give you, times this squared times this.
It's more than that.
So what is our volume?
Million, something like that.
595.8.
It's a billion. It's 10 to the 9th. So when I get a question like this, what I will do
595 okay.
is I will start with
cubic
what we
centimeters.
have.
Okay, so that is our volume.
So we start with,
and we need to
what we
convert
have. That's
volume
the number we have
to a mass.
So let's write that
So we
down.
use density to do that.
5.51 times 10
So let's
to
get
17.
rid of this stuff. So we've got
Now, what I want to do, basically, actually,
now
I'm
we
gonna
just
put up the
convert
screen so I have a
our
little more
volume
room.
to a mass. So how do we do that?
I set it up as 2.7 equals mass over
Was it
595.18.
5.51 times 10 to the 17th, I think it was.
Wait a minute.
Nanometers?
So,
Okay.
What did you do?
So I want to get from there.
Density is mass over volume.
I want to get
and
to
since
kilometers.
the volume of the rod, I put that
Right. So I
on
need
the
to go
bottom
from
and then
nanometers to kilometers.
I made that equal to
So what I'm going to do,
2.7 so that we
since
could
I
solve
know
for
the
the mass.
relationship between nanometers and meters.
Why would you
kilometers
divide
and
by the
meters,
density? I don't get
I'm basically
that.
going to go through.
Why does this go in?
So we're going to
Why does
convert
the
my
volume
nanometers to meters
in
first. So
we
when
want
I
to
do a
end up
conversion,
with a
basically,
mass,
what
right?
I always want to do is
Yeah.
put the unit.
And
I
so the
want to
density
end
has
up
mass on
the
top and volume on the bottom.
And then
So
the
why do we
unit I
want
wanna
to put
get rid
volume
of,
on this
I put that
volume
on the
as a
bottom.
denominator? We want to get rid of it.
Because what we can do is
Oh,
if we have a unit
well, that's just how I
on the
initially
top
set it up. But
and
after
on the
that, I
bottom,
did
like as a numerator
2.7
and a
times
denominator, we can cancel those out.
595.18.
Right. So that's the way to do it because we
You
have
should get used to
centimeters
this sort of thing
cubed
because we're going to be doing it a lot.
that's our unit.
So how
So
many?
we want
how
so
many
centimeters
nanometers
cubed is in the
a
numerator.
meter? I think we've figured
In
this
our
out.
density, it's in the
There's a
denominator. That's
billion,
exactly
right?
what we want because then we can
billion is
cancel
10
it
to the
out.
what power?
And the unit we're left with is in the
10 to the
numerator,
ninth,
and
that's
that's
right.
mass, and that's what we want.
Now we could
Right.
also
So
that should
595.18
make this a little
times
we could also
2.7.
have put that.
That goes back to why I
1 times 10
always
to the minus
multiply
9
and never ever
meters.
divide.
You see
I
here,
always
it's a 1
multiply because then my units are
Both
in the
those
right
things
place.
are true.
You know, I can always follow
I don't know. I just kind of
where
like
my
working
units
with
are.
that.
If I try and divide anything,
So
then
since
the
we
units,
have
it's much
nanometers
more
on the
difficult
top
to
and
figure out what's
nanometers
going
on the bottom, I can now
So this way I've
cancel
got
those out.
centimeters cubed in the numerator,
And now
then I've
I'm
got
just left
centimeters
with
cubed in my
meters.
denominator.
But I don't want meters. I want
I can
kilometers.
eliminate those. So
we're gonna
whatever
do
I'm left
another
with That's what I
conversion.
want. I want mass.
So I want
So what's my final
kilometers
answer?
at the end. So what do I put on the numerator? I put
I got
kilometers. What do I want to get rid of now?
1,610.
I want to get rid of meters.
1,000.
So how many meters are there in a
1,610
kilometer?
grams?
Grams.
1,000.
Now, how many
That's
significant
right.
digits should there
1,000.
be in the final answer?
So we can either put 1,000
Three.
or we can put 10 to the
10
what
to the
power?
3.
10 to the
Why is
3.
that?
Right. So 1 kilometer is 10 to the
4.85
third.
and 6.25
meters. Now I got rid of
both
meters.
3 significant figures.
Mm-hmm.
And the only
How many?
unit
That's right.
I have left
What about the density, though?
Kilometer.
is kilometers or
I thought the
or
density was
kilometers.
just like
That's it.
kind
So
of like
now
the
I
conversion.
just
So
do
it was just like
the math.
a number there for you to use.
No,
So I have
unfortunately, no. Density is
10
also
to
a
the
measurement.
17th on the top.
So would it be 2
and I have 10
significant
to the
figures?
9th
That's right.
and 10 to the 3rd.
Yeah, that's a tricky
on the
one
bottom.
because
10 to the 17th is a numerator.
it's a
And
unit
10 to the
conversion,
12th.
yes, but it's also a measurement
as a denominator. So what am I going to have
because
left over?
we have to
do
measure
this math.
density, right? Because it's just a ratio of mass and volume, and you measure both of those things. You
Yeah,
measure
I have
mass and you measure volume.
5.551, 10 to
So
the
when
17th.
you put them together, basically it's
On
a
the
it's a
top,
ratio of 2
10 to the
measurements.
12th on the
So
bottom.
it's still a measurement.
Right. So basically,
So this isn't precise.
get rid of that.
So we're
17
limited by
becomes
this
5.
precision. So the real
Uh-huh.
answer is
So
1,600.
now my final
okay.
answer is 5.551 times
Yeah.
10 to the 5th.
Or 1.6 times 10 to the third.
Yeah, but
Basically,
that is
we're
the basic
limited
way
by
I go
by that.
about
We're limited.
Some people
Our precision
wanna say,
is
well, I can
limited to
make
2
the jump in
significant digits
one
because of the
in one
density.
conversion.
There's nothing we can do about that.
I would recommend
Unless we
not
looked up a
doing that.
better
And the
density.
reason
I think
is
aluminum,
I find I make
if you look
lot
up
more
the density of
mistakes
pure
when
aluminum,
I
it was
try
like
and
2.7
directly convert from nanometers
or something
to
like that.
kilometers.
But if
I don't go
if
through
you use the number
meters,
you're given.
I find I make a mistake because I
Right.
know
Excellent.
how many
let's see,
nanometers there are in a meter. I know that for sure. I can
A
look
few
that
more
up.
to go, and we'll call it a
I
day.
can
If anyone
look
needs
up
to
how
go
many,
right ahead.
meters
Because we're
there
going to
are
be posting
in a kilometer. I can remember
the
that.
answers.
But if I
for
try
you.
and do the conversion all at once, I will
So don't feel like you
almost
need to
always
you need to
make a
hang.
mistake. I
So
will take my
number
10 to the
9.
ninth and
So
10
back to
the
group
third, and then
1.
I will turn that into 10 to the 6th
You
somehow.
want to go through that?
I make dumb mistakes like that all the time, which is why I try and make it as hard as
One?
possible to make stupid mistakes.
Or anybody
So I
else?
go
Yeah, sorry, I
through
couldn't-
these,
I couldn't unmute my mic.
conversions as carefully
Oh,
as
no
I can,
problem.
and I don't do shortcuts.
No problem.
Even
All right,
now,
let's go to the-
I've been doing these things
Okay.
for 40 years.
I was kind of going along
I
also,
always
so I'm not here
show
yet, but
every
I'll
single
do
step
it while we're
because
here.
if I show every
Okay.
single step,
So
I
where
can
do you
see
start?
where it is I
What's
made
the
a
first
mistake.
number you've got?
It makes it much easier to figure out where I screwed up.
Okay, number 9. How
by
many
every
iron ball
single
bearings?
step. If I take shortcuts, it makes it much harder to find
Small
where the
bearing.
mistake is. although it's
Oh,
easy.
this is a lot. Okay, so
Okay, shall we do?
I guess
do,
so. The
do
first
one
thing to
more and
do
then we'll
is-
go back into breakout rooms. Let's have a look at the next question.
do all the iron.
Wait, Professor.
Oh, go
What
ahead.
numbers do we have to start with?
Do you know the lean?
So we have
To
a
the-
diameter.
To PDF.
You need to make
To
3
BF.
meter,
No,
3
to your
millimeter
PDF,
iron ball bearings
the worksheet.
So 3
From-
millimeters
Oh,
in
yeah,
diameter?
It's in the
with a
it's in the
diameter.
chat.
How many?
Jexy posted.
Yeah. So
3 or
You see
3.0?
it?
oh, sorry, 3.00.
3.00 millimeters.
Hmm?
Okay.
It's also
Okay,
in Canvas.
and you got to make.
Yeah, it's also
Oh,
I guess you
it's
have
also
to-
yeah, if you can't find it in the chat, have you
It's
got
just
the
how
chat
many
open?
can you make
Mm-hmm.
with
Do you know where to find that?
10.0
Okay.
kilograms
Do you see
of
it now?
iron ore. That is 47% iron.
You're breaking up on
Okay.
it.
So I'm guessing you have to find out.
Is that all the information you're given?
Yeah.
You got it?
Are you given the density of
All
iron?
right, cool.
Yeah, I got it, Dickie.
All right.
Because
Yeah,
it's impossible to answer without it.
Okay.
Yeah, I was going to say. So you have, yeah.
There's
So
a lot
density of
going on.
iron is
So the pressure of a
7.874
bike tire.
grams.
So we have
per-
128 pounds.
874 grams per cubic centimeter, right?
Inch. And that's
Yep.
the way
Yeah,
like
okay.
Americans typically look at
Okay.
tire
So what's the very
pressure.
first
Like,
thing you
ever,
need to
check
answer?
The pressure in your car.
Okay,
it would
first
be
thing you
in
need to
pounds 'cause
answer
they range
is
your PSI.
how
everywhere else in the world will be like, kilopascal.
It's gonna have to
or
be something
some
with
other
the iron ore.
pressure.
Yeah,
Still use
exactly.
PSI. 100
That tells you, because you don't know how much iron you have. You need
Yeah.
to know how much iron you have. So how much iron do
we
you
want to
have?
convert that to grams.
So you only have 47%.
Mhm. So if I
So I'm
multiply
guessing
that
you need
by
to
47%, what am I actually multiplying by?
Whiteboard.
0.47.
Right.
All right, so let's start with what we have.
So that gives me how
what we
much
have
iron?
is
4.7
120
kilograms of iron.
pounds per inch
Oh, sorry.
squared.
It's
Now that's important. That squared is really
we're doing
important. And
It's 10.7
actually
kilograms,
cubed,
not
right?
10.
Per cubic inch.
10
What am I
points.
saying?
Did I get
Cubic
that?
inch.
Let me see.
Erase that.
Is it 10 kilograms or 10.7?
Because it's a volume. It's going to be inches cubed.
I don't know if I
So what
think
do we need to do?
I might
We
have
need to
wrote it wrong
convert
on
that.
my paper.
We need to
I think
end
it's
up
10.0,
grams.
isn't it?
No, let's see.
per cubic centimeter.
Let me find it.
So we need to make two conversions. Which one is the mass?
Yes, it is 10.0. Correct.
Okay, yeah, 10 points. So it's 4.7, right?
Yes, so that's
Grams is
4.7
one.
grams.
What's the other one?
Okay.
4.7 kilograms.
Pounds. Right. They're both units
Okay.
of mass.
So what's
So
next?
that's mass
So
and that's mass.
now
What
you
about
need
volume?
to find out how many iron balls can be made.
Just inches.
So right now you have mass.
Oh,
you
now
wanna-
you need to find
And you want to
density
convert mass
to
to a
density.
Right.
number.
Those are volumes.
Or,
So
In
yeah.
order to convert mass
So
to a
an inch
number,
would be a measure of length.
basically we need to know what
Inches
the mass
squared
of
would be a
one of
measure
these things
of
is, right?
area.
So that's the
And
way to
inches
proceed.
cubed would be a measure
I need to
of
convert
volume.
mass to a
So
number. Well, I
there's
can't
our
do that
inches
unless
cubed
I know what the
volume
mass
and
of
centimeters
one of
cubed
these
volume.
things is.
So
and then
we
I
need
can
to
do
convert both of those.
So what's going to be
So
the
we're gonna
mass
start
of
by
one
converting
ball? We need to figure
pounds
that out.
to grams.
Okay, so I think it's
So I'm going
3
to put
times
grams on the top,
7.874.
right? Because I want to end up with grams.
Right.
And I'm going to put pounds
This is
on the bottom.
this
Oh,
is
that's
a
centi- I
diameter.
gotta-
This is
oh,
a
you're
this is a
right.
diameter.
We got it. We also have to
How many
change.
grams are there in a
We
pound?
need the volume,
Yeah.
right? We need to have a volume of one of these balls because density is the ratio of mass to volume. So we need the volume of one ball bearing.
454.
So what is the
Do any
formula
more
for the
digits
volume
than
of
that?
a sphere?
Oh, it has to be precise?
I think it's
Oh, yeah.
like
So
Well,
400.
the thing is, you
Pi.
use as many significant digits as you can find.
pi?
Like
All right.
that's another thing I'll want to point out. When you're doing these sort of problems, use as many significant.
Anyone help
digits
them?
as
Anyone
you
have
can
that
find
on
and
them?
Carry those significant digits over.
Volume of a sphere.
four. It's 4 over 3 pi r
When you
cubed.
get to the
There you
end,
go.
then you can round. But do
So
not
our
round
volume
anything
is
until you get to
4
the very
over
end.
3.
So how many significant?
pi
So use
r
a lot of significant
cubed.
digits.
Now
As
we
many
have a
as six.
diameter. Is that the
So
same as
four-
the radius?
54.6?
No, it's gonna
No,
the radius is gonna be 1.5
453.5.
1.5 what?
453.
millimeters.
Millimeters.
Sorry,
Now, do we want
592?
millimeters?
Yes.
No, we want centimeters.
Yes, we do. Exactly. We
Excellent.
want
Okay.
centimeters because centimeters
Per pound.
is the unit that our density is
Now,
given.
this is the tricky part.
So
I want
we
to
have 1.5
centimeters
millimeters
cubed on the
is our
bottom.
radius, but we don't want millimeters. We want to
So I'm
convert
going to
that.
want to have inches
So I'm going to
on the top and centimeters cubed on the bottom.
Converted to
So the question is,
yep, I'm going to convert
how
that to
many
centimeters.
centimeters
Yeah.
are there
Let's
in
do
an
that.
inch?
So I'm going to multiply that by, I want centimeters now. I don't want millimeters.
2.54. So I'm going to put 2.54.
So how many
That's
millimeters
right.
are there in a centimeter?
There's
In one
there's
inch.
10 millimeters in
Now.
every centimeter.
Yep.
Interesting thing about
So when I
centimeters
do that,
and
my
inches.
millimeters are gone. And
You
now I
find
have
more significant digits than
0.150
2.54.
centimeters. So my volume is 4 divided by 3 times pi times 0.150 centimeters.
Wait, isn't it?
No, you can't.
Are we
Because 1 inch is
are we converting it into
exactly
millimeters or
2.54.
centimeters?
It's not an estimate.
We want
It is
centimeters because that's what our
exactly
density is
2.54.
given.
It's just a weird thing.
Oh,
So
you're right.
that's
You're,
the-
yeah,
So our
okay.
density
It
is in
exactly that
centimeters
number.
cubed.
Yeah.
So we got to have
Okay.
centimeters cubed
How many
for our
significant
volume.
digits
I
are
was
there
doing
in
it backwards.
2.54?
Yep. So the volume of one ball bearing is
an infinite number, because that is not a measurement. That is exact.
I gotta remember where my
that is exact. That is one of the very, very few times that this comes up.
Mine is either.
This is one of the
I forgot where it
things,
was.
2.54.
Actually, mine doesn't have one.
1 inch. It's not.
Pretty sure mine has one.
It's
Oh, there
not
we go. It's
close
the.
to-
It might be on
close
your
to it.
exponent.
It is. It's not
like
precise.
arrow.
It is exact. There's.
So I don't even use a sign. I'm too dumb to
What
use
else
a
do we need
scientific
to do? Now, if I just
I
multiply
need the
1 by over
senior citizen one with the big
2.54,
button.
That's correct.
Oh God.
That and my fingers are huge, so I need to.
Okay, I got
2.5.
0.0141.
That's right. Very good.
So-
Excellent.
So 0.
I need to cube this.
What is it?
Because 1
0.0141.
so that means 2.54 needs to be cubed as well.
37 what?
That
What's-
is a
Remember, a
mistake
number without a
that we
unit
make
is useless, so we
all
need to
the
have a
time.
unit at the end.
So I need to
This is gonna be
take my 2.54
centimeters.
times 2.54 times 2.54. I need to cube all of them, because we'll find
It's just
out
centimeters, right?
that
Nope.
Are we
1
cubed?
cubic inch.
Yeah, 'cause we
is
cubed it,
many
right?
More
Because-
you're right.
because we have our
it's
our
11.
radius is cubed. That's
So when we do all of
and
this,
anytime you have a
multiplication,
volume,
so we'll take
it has to be a
120
unit of measurement cubed, because
times
measurement in just
4.53
unit of measurement is length, and then
592
measure of unit squared
divided by
is area, and then measurement of unit
2.54.
Oh, hold up. I don't
the
think that's right.
measurement
Actually,
cubed is then volume.
and we're going
I
to
don't
be
think
left
that's right.
with
I didn't
pounds are
cube
gonna be gone,
the final
Oh,
answer.
yes.
Actually, no, I did.
0.15
Sorry, I'm right.
and we're going to be left with grams over cubic centimeters.
I think that was
What-
right.
What is my number?
Yeah, you're right. I got
Okay,
the same
yeah.
thing. Yep. So that's our volume. So now we need to convert volume to mass. And how do we convert volume to mass?
Yeah, that was a bad one.
With
Density.
density, exactly. So now all we need to do really is just multiply that by our density. Why? Because
3,321
density has
points.
mass in the numerator, and that's what we want, and it has volume in the denominator, and that's what we want to get rid of. So
Okay,
it's
now
set up
go
perfectly.
back to the original.
So we just multiply that by
problem.
7
How many pounds?
7.4
Was it
grams
120 or was it
per
120
cubic centimeter. I get rid of my cubic centimeters. So how much does one ball bearing weigh
120 dot.
in
It
grams?
was 120 dot. What does that mean? Why is that
0.11.
dot there?
How many
What does
significant?
that
We're
mean?
doing 3.
This is
0.111.
No. Here's a really important lesson.
Nope.
Don't worry about significant
Why do we
digits
put a
yet.
dot there? What's the difference? I'll
Put
put
out
it
as
this way.
many
What's the
significant
difference
digits as you
between
want.
120?
Only don't round too
120.
early, because when you
Dot.
round too early, you limit the precision of your final answer.
Is there a difference?
120
So-
without the dot
Yes,
is
we can really
like
only give
an
we can only
approximation, where
report 3 significant
120
digits in our
is exact.
final
Like it's
answer.
not rounded.
But that doesn't mean we
120
need to
without the
limit
dot could be
ourselves to
rounded.
3 digits in our calculations.
Okay,
Use as
so
many
what does
as
that
we
mean
want.
as far as
Go hog
significant
wild. You can
digits
use
go?
like however many your calculator holds,
120
like
with the
okay,
dot has
like
3
10.
significant
Use all of
figures, and
them. Don't
without the
worry
dot,
about
it's
it.
2.
Wait till you get to
There
the
you
very
go.
end.
Right. Very
Then
good.
round.
Yeah, the
So,
dot
yeah, that's
just
important
means
lesson
that
learned for today.
that zero.
So what's our
is
the mass of 1
It means
is
that it's not
is
100
how many
and-
grams?
It's not between
111316525.
124.
That's probably enough.
That's what that means. It's not between those.
That's
It
probably
means
good.
It's between.
All right. So that's one. That's the
119.5
mass of 1. So
and
let's
120.4.
erase all this other stuff.
So it's
You
more
can see
precise.
this takes a long.
It's
a lot
within
of
one
calculations.
120. Whereas 120 without it
So that's the mass of
means it's
one
within 10
ball.
120. That's really what that means.
So how much iron do
Plus
we
5
have?
minus 5.
We have
Means it's within 10 of 120. 120 with the dot
kilograms
means
of it.
it's within
Kilograms,
1.
right? But we don't want kilograms, do we? And
No, we need
120.0.
grams.
Right, so we have 4.7
How many significant digits in 120.0?
Zero. right? Kilograms.
Yep.
3 significant digits. So we want to convert that to
4.
grams.
Right, because
so
that
the grams
now,
on top,
the 0.0
kilograms on the
means it's
bottom.
within 0.1
How many grams in a kilogram?
of 120. So it's
There's,
each time we put zeros behind
1,000
the decimal
grams
place,
in a
it's
kilogram.
getting more
Yep.
and more and more precise. So
So
how many
that gives
significant
us
digits should there
4,700
be in our answer?
grams.
Yep.
So then we take our 4,700 grams
So we've done all this math.
times 1 bearing
Why 3?
Because since that
is how many grams?
decimals there, it's 3 significant figures.
Yeah, actually, yeah, it means
What?
we
You
always
just
revert
calculated
when we're
it.
doing when
Oh,
we're doing multiplication and division.
0.111316.
We always
Yeah,
refer to the number that is the
0.1160
smallest number of
grams.
significant digits.
So,
because
because
basically
this
we're
is a
limited
conversion, right?
by
We
the
are
precision
converting
of that
ball
number.
bearings
We can't
to
our
grams.
answer can't be any
We're
more
actually
precise than the
converting
least
converting
precise
grams to
number
ball bearings.
when we're
So our
doing
grams are gone,
multiplication and division.
and the
When we're
only
doing
unit
addition,
that's left is
subtraction,
ball
it's different.
bearings. So
But
what's
when
our
we're doing
final number?
multiplication and division, we're limited by the least precise number. And the least precise number here is 120.0.
You gotta do
120 decimal. So 3. 2.54 is an infinite number of significant digits, which sounds weird, but it is. Since it's an exact number, we don't consider that. And we have 6 significant digits here. So the number with the least number of significant digits is 120.
what is it? It's
So
it's
what
4,700
final answer?
47
divided by 0.113160, blah, 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 blah.
Okay, I was right. Yeah, 40.
3.30.
No, that's not right.
Times 10 to the.
Is that right? 42,222.
So 3.3
42,222?
10 to
Yeah.
the
222. Okay, so now
I guess that's right.
we deal with
Or you
significant
could also
digits.
put 3,000.
So after you've done all the calculations all the way through,
That is-
now
that
you deal
also
with
has 3
significant
significant
digits.
You don't
So-
always have to put it in scientific.
How many significant digits did we have for math?
So if you're doing a problem on a test or
3.
something, and
3.
it doesn't say
So
specifically
we
to
can
put it in
only
scientific notation,
give our answer can only have 3 significant digits.
if it does say do it. In
So how do I
scientific
take
notation, then
this number
You have to.
and convert
Yeah,
it to
either one of those
to
answers
3 significant
would be
digits?
fine.
Well, I guess
All right,
first you
cool.
see if you can round anywhere. You just
All right. So what I'll do
the
is
42 you keep, and then the 2 you just create that
go
into
back
200.
to the
Yeah. So
So
42,200.
hopefully everybody has.
Yeah.
So we're going to work on.
That's your final answer.
Actually, you wouldn't round up in this case, would you? You would just
Nope.
These problems, the
No.
scientific notation,
Yeah, and
significant numbers.
you're basically stuck. The
can start with this
42,200 is
problem,
as accurate as you can
the
be.
one matter. Make
Because
a
you can
list.
only
I'd
be as
curious to see
accurate
what
as
you come
the
up with.
number you're given. So if you were given a more accurate
Some
mass,
kind
you
of
could give a more accurate
list
number
of
ball
matter
bearings
that you
when
encounter
were given
every day.
free.
And it should have
Digits.
solid,
So
liquid,
you're limited
gas,
to
and
that
element,
many
compound.
in your answer. Okay?
Homogeneous mixture.
Yep. So what if you had like say like 299?
These are
You can't
pretty
say
quick.
300
1, 2, 3, and
because
4.
If the number given is
Have we
299,
gone over the difference between
then
adding
you have 3
significant
significant digits.
and multiplying significant digits?
And you use all
no, I
three.
mean like if it was like 40,299.
Okay, we'll review
Yeah, then
that.
it would be
And
42,000.
then the dimensional analysis.
Anything more than 42, anything more than
Finish up on those.
249,
So that everybody
you
should
round
be
up. So if it was
prepared
250, you would round
to
up.
present
Okay.
2 of
Yeah.
these, since there's like, how many?
But
Total
49
10
or less,
questions. So it'll be 5,
round down.
14. Everyone should be able to.
Okay. And
To
any other questions
three
before we go? We sort of kept you late here. I apologize. We're going to post all the answers, so you can check your answers.
Benjamin and I are going to go.
Anybody have
around
any
and
other
check
questions
on you.
they want to
We
ask
work on them
before we
for,
go?
let's give us a time, let's say 45
Either
minutes
on
or
this
so.
question or any of the other
And we'll
ones.
break, and then we'll come back together and
Is there one you
if
had
don't get them
problems
all
with
done,
you couldn't
that's-
answer?
That's fine. We'll work on them together because you don't need to submit these.
I'm actually
This
going
is-
to be
this is
taking the
basically
extra
practice
class on
for-
Tuesday,
for
so any
tests.
questions that I have, I'll be asking the teacher then.
Yes.
Does this
Okay.
class end at 3?
Okay, that's fine.
3:10.
All right. Anybody else?
Yeah.
you.
3:10. Yeah, it's two hours. Though
Okay.
we can go longer if
I will.
if people want to.
So I will talk to
want
you
learn past 3:10
next Tuesday.
It's not like
Finally
I'm not
get
gonna
to
allow it.
do an experiment. I'm looking forward
If
to.
people
it.
want to stay.
So hopefully everyone has their
that's
their lab equipment,
till one of my dogs eats my leg.
and we'll meet up at the same time on Tuesday.
All right. So why don't I'll deal with
Roger.
get the breakout rooms
Come say hi.
together.
This
Hi.
is
Hello.
Roger. Breakout room.
Hello.
He's the littlest chemist. So anyway, so we'll see you next week.
All right. See you on Tuesday.
Okay.
Bye, everyone.
Bye.
Thank you. Have a good weekend.
You too. I'll set it up,
Hi,
and then,
Professor.
like I say, so just start. You can even split
Are you
up
able to hear me?
the problem. Oh, yes.
Oh,
You can
yeah.
each work on
Just
one and
quick
but what I want you
question.
to
I mean,
do
I'm
is
still
work
on the wait list.
together.
And
So it makes
it's
these
pretty
go
much the end of the
much
week,
faster
and
if
I
you work
didn't
together.
sign
What
up
I'm
for a
going to
lab
do
kit
is
just because I don't
find
want to take someone's
the
kit if I'm
table.
not in the class yet.
What do you know? What number you were on the wait list?
Yeah, I'm still number 4. So I was like,
And you haven't moved up at all for you guys to.
well, I actually was like 7, and then I think I went down.
Oh,
to
so you have moved up.
Well, I have moved like just from this week already, but it's, I think I'm like more afraid that it's like now the material's getting more like we're doing more work. I mean, I'm still going to class and taking notes, but just from, I guess, maybe your experience or recommendations, should I just keep sticking it through? Because I'm not too sure if there's like a refund date for people. Like I'm just waiting for that to come, and then have people drop out, so at least I could take a spot, or like if by.
Oh yeah, but you don't have to pay to get on the wait list, though, do you?
No, I don't. It's for me to just think about like maybe my chances of like getting in still. Let's say like there's.
Yeah, I'd ask Dr. Schubert, because I don't have access to the wait list, so I'm not sure how many were there at the beginning and how many there are now.
Mm-hmm.
I mean, if it's gone, if we've already added like 10 from the wait list, then you're right. We probably won't add any more. So, but I'm not sure. If we only added like 1 or 2, then there might be a chance. So I would write her and ask, like, what the chances are. Though after 2 weeks, we generally don't really add too many after that.
Okay, yeah, I'll stick it out for next week then, and maybe talk to her optional lecture.
Okay.
Thank you, Professor.
All right, no problem, Angela Rose. I'll talk to you later.
Bye.
All right, bye-bye.
Hi.
Oh, yes.
I just wanted to tell you, so I've been going to Dr. Schubert's classes by accident. I was a little confused.
Oh, the lectures, she's in charge. She's large and in charge of the lectures.
Oh, okay.
I'm just doing the recitation for one group and the lab.
Okay.
So,
well, I've been going to hers, and she told me to let you know, like, that I had gone to the wrong ones.
Oh, no problem.
All right. That's
No problem. Yeah, I mean, the first recitation was really just sort of let's all get to know each other kind of thing. So, yeah. Hello. So, not an issue. So you're going to be with me for the rest of the term. Is that it?
Yeah, that's it.
And Jerome here.
All right. Thank you.
Okay. All right. I'll talk to you later. Have a good weekend. You have any questions, Ezekiel?